Most welcome, dear, and thank you for choosing my lecture. This session is going to be very interesting because we are covering Biot law, which is very important for BSc and 12th physics student. So let's begin. Basically, this law is used to determine the magnetic field strength at any point due to a small current element, which is a part of current carrying conductor. Let us consider first let it is a current carrying conductor, and current I is passing through the wire or current carrying conductor, and if we choose a small segment which we can call small current element, that is called small current element. Every part or every segment of this current carrying conductor is a small current element. Understand? Okay, we choose this part as small current element, and there is a point P. Okay, so the distance between the center and the point P is r vector. Okay, and the angle between the segment center and the point P, the distance is theta, right? We have to define the magnetic field intensity at point P due to this segment. The length of this segment is dl. Okay, so let's find. Let me write down something. According to Biot-Savart's law, the magnitude of magnetic field intensity, the magnitude of magnetic field intensity see guys, dV, let dB at the point P due to the current element dl is at point P due to the current element dl is first. We know if the current flow increases, then the magnetic field also increases, right? Yes or no? Yes. So the first equation is dv vector is directly proportional to current I. It is equation 1. And what will be the second equation? The second equation is if the length of this wire or this segment will increase, the magnetic field also increase, right? If the segment if the length of the segment is decrease, then the magnetic field intensity also decrease. Yes or no? So write down dv directly proportional to dl. dl means what? dl means length of the segment or current element, right? And the third equation is dv vector is directly proportional to sine theta. It is equation 3. And how it comes? You see, if the point P is there, then what will be the magnetic field intensity? The magnetic field intensity will be 0, because the direction of electric field and the magnetic field is 180 degree, right? And if we consider P point is there, what will be the magnetic field intensity? Magnetic field intensity also be 0 at 0 degree. Yes or no? Because we all of know magnetic field goes perpendicularly like this. If the point P is in this point, or the angle between this is 90 degree, then it is the maximum of magnetic field intensity will be maximum at this point. So remind the trigonometric function, which function is same like this. We know sine 0 degree equal to 0, sine 180 degree equal to 0, and sine 90 degree is maximum. So dB vector proportional to sine theta. All of you understand? And the last equation is dB is inversely proportional to 1 by r square, which is the 4th equation, and r is the distance, right? We know if distance will increases, magnetic field also decreases. If distance will decreases, magnetic field increases, right? Now combining all equations, we get dV proportional to IDL sin theta by r square. Yes or no? Right? So this is the output of all the combination of equation, right? Now we replace the proportionality symbol with proportionality constant. So what will be the proportionality constant? Will be equal to mu naught by 4 phi ideal sin theta by r square, where mu naught is absolute permeability of free space, and the value of this mu naught is 4 phi into 10 to the power minus 7 Weber, right? So this is the Biot-Savart's law. If you want more videos, then subscribe our channel. Thank you for watching. Take care, all of you. Thanks.